All right, let's continue. So, now we will get into memory testing. So, memories are of several types, right. You may have heard about read only memories. You may have heard about read and write memories or random access memories. Okay. So, read write memories, as the name itself indicates, they can you can write into that memory and read back from the memory. Under RAM you may have SRAM or static RAM, and you may have dynamic RAM or DRAM. There are also, these are volatile memories. Meaning, if you power off this memory, then you will lose all the contents. There are also non-volatile memories, where you can write to the memory, but the content will not be lost when the power is turned off. The read only memories are programmed in the factory. So, you cannot write into them, the user cannot modify the content. So, where is ROM used? ROM can be used to store information that does not change. Okay. So, ROMs can be used, for example, to store maybe some boot code in a computer, or maybe it can be used to store tables, scientific tables like logarithms, sine, cos and things like that. So, these are the applications of ROMs. Okay. Information does not change, it has been written to at the time of manufacturing the ROM, and you only read from them. RAMs are used in a large number of applications, including computers. Right. SRAM is typically used to build cache memories, because they are faster, whereas DRAMs can be used to build the main memory. DRAMs are typically slower than cache memories or the SRAM memories. You may have also heard about flash memories. You may have heard about programmable ROMs or PROMs. In a PROM or a PROM, the information can be changed by the user. It is not like a ROM. In a ROM, the information can't be changed, but in a PROM, the user can write, okay, but it requires a higher voltage. and it is assumed that write is going to be performed very few times. Okay. In the same way, flash memory, you will program the flash memory periodically, maybe once in a while, and then after that you just use or read. So, you are only reading after you program. So, this is useful in microcomputers or microcontrollers. These microcontrollers can be used in a number of control applications, right? And microcontrollers typically store the program and data in a flash memory. And usually we do not change that, okay. But occasionally you may need to change it. Maybe you have a newer version of the program that has become available, then you can rewrite to that flash memory. So, there are several kinds of memories. So, when we talk about memory testing, we could be talking about testing of non-volatile memory or testing of volatile memory like SRAM and DRAM. Okay. So, let us first look at RAM, which is very often used in computers. Why only computers? It is used in just about all applications. See, in any computer you will have a central processing unit and you will have a memory. The memory is used to store both programs and data. So, this is where RAMs are used, because you will have to load the program which may be sitting in a hard disk So, from here you have to load the program into the memory, because the CPU cannot afford to read the program from hard disk, it is too slow. So, usually there is what is called as a hierarchy. So, there is a CPU which has some registers on chip which are very fast. Then there is a cache memory which is fast, but not as fast as these registers. Then there is the main memory. And finally, there is a secondary memory. So, here we look at hard disk. You can also talk about the cloud. Nowadays, we like to store the information on a cloud, and with the help of a network, we are able to get the data whenever we need. Some people will also refer to what is called as tertiary memory. That refers to things like USB drive, right, where flash memory can be used. So, you can have infinite of this, right. That means I can purchase as many tertiary memory as I want. It could be the CD, it could be the USB, right. There is no limit. Secondary memory, today it is not uncommon to find many gigabytes or maybe even terabytes, right. So, hard disks will be usually in terabytes. Even main memory is nowadays in gigabytes. And cache may be in megabytes. So, this is known as the memory hierarchy. Notice that as we move down the hierarchy, we can afford to have more and more of that memory. The reason is cache is very expensive. So, this is usually made from SRAM. Main memory is not as expensive as cache memory, but it is still expensive, and this may be made out of DRAM or even SRAM. Secondary memory is your flash and hard disk, etc., etc. And as you know, this can be infinite. We can store our data in some other server and we can fetch it whenever we require it. So, as we go down the hierarchy, the cost decreases, performance degrades. See, it is very fast when you find the information on your computer, let us say in the cache. But if you do not have it in the cache, you have to go and look for it in the main memory. And if it is not in the main memory, you have to look for it in the secondary memory. And if it is not in the secondary memory, maybe it is present somewhere in the tertiary memory or somewhere in the network somewhere. And performance degrades, and unfortunately memory is also highly likely to have defects. See, think about it, we are talking about megabytes of memory, gigabytes of memory, terabytes of hard disk. So, the chance of a fault present in these is very high. Even if the chance of a single memory cell going becoming faulty is a very small number, right. The number of memory cells is so large that this memory is likely to have faults. So, unlike digital tests, see, when you have digital circuits, if there is a fault in the CPU or something like that, we will not be able to use that chip, we have to throw it away. Okay. So, a fault here can make the chip unusable. But if there is a fault in the memory, we do not want to throw it away, right. We may be able to circumvent the problem. So, if a memory location has gone bad, then we will store the memory information in some other location, we will not store it there, right. There could be a bad block on the hard disk. So, we will not store the data there, we will circumvent and go elsewhere. So, in a way memories have some sort of redundancy built into them. That is not true about CPUs. Now, let us look at a very popular SRAM cell. Okay, how is an SRAM constructed? So, an SRAM cell is built out of 6 transistors. Basically, it consists of 2 inverters connected back to back. Like a flip flop. Okay, there are 2 inverters connected like this. So, notice that if we have put a 0 here for somehow, then this inverter will produce a 1 here and that will produce a 0. So, this is one stable state. And there is another stable state, which is we have a 1 here. So, these are the only 2 things that can happen. There are only 2 stable states, and we can treat this as the output and say it is storing a 0 here, it is storing a 1 here. So, the inverter is constructed using CMOS technology. So, this is one inverter, and the other inverter is like this. The output of this guy is connected as input to this, and the output of this guy is connected as input to this. So, we have used 4 transistors, 2 PMOS and 2 NMOS transistors. In addition to that, there will be 2 more transistors. And these are connected. So, these will be connected. And there is usually a wire here and a wire here. So, this brown line is what we call as a word line, and these are called bit lines. One of them is called bit line, the other is called bit line bar, and this is called as a word line. So, as I mentioned, these 2 inverters are connected back to back, and they will either store a 1 here or a 0 here. Now, how do I write a 1 or a 0? See, we have to write and we have to read from this cell. Okay. So, that is where these word and bit lines are useful. If you want to read or write from this cell, we have to make word line high. In other words, we are selecting this particular cell by making that word line high. So, both these transistors will be ready to conduct at that time. So, if you want to write a 1 into the cell, you will make BL equal to 1 and BL bar equal to 0. So, when this conducts, you have provided a 1 here, that will cause this inverter to produce a 0, and it will cause it to produce a 1 here. In the same way, if you want to write a 0, you can write BL bar equal to 1 and BL equal to 0. So, this will cause write a 1, this will mean write a 0. What it means is this is the output, we treat this as the output. So, BL equal to 1 and BL bar equal to 0 will cause the output to become 1, the cell has a 1 now, and when BL bar is 1 and BL equal to 0, we write a 0, that means we can see a 1 here, I am sorry, we can see a 0 here. When you want to read, you make both of them 1. You make both BL and BL bar 1, these are called bit lines. So, they are made 1 by what is called as pre-charging. Now, if they both become 1, depending on whether the cell contains a 1 or a 0, right. Imagine that this contains a 0 and we have made this 1. Okay. What will happen is this guy will sort of charge, BL will sort of charge the this okay. So, I was considering the case when this is 1 and this is I am sorry, this is 0 and this is 1. So, this 1 is causing this guy to conduct, and now you are trying to bring in a 1 from this side, okay, and you will see a small reduction in this voltage. So, there is a weak or there is a very small drop in the output voltage BL, okay, and that can be sensed using what is called as a sense amplifier. So, there is what is called as a sense amplifier to which this BL and BL bar will be connected, and that will recognize the small drop in the potential, and using it, it will figure out whether the cell has a 1 or a 0. Similarly, if this was 1 and we applied a 1 here, and this had a 0 and we applied a 1 here, you will find that this guy will try to discharge, and there will be a small drop in the potential of BL bar, which can be sensed by the sense amplifier. So, notice that a lot of things can go wrong in this 6 transistor cell, right. There could be a fault anywhere, maybe one of these cells is maybe this transistor is permanently on, maybe there is a short circuit between the two gates, maybe one of the PMOS transistors is on permanently or off permanently. So, so many things can occur.